Welcome back to the deep dive. I'm excited for this one. We're going deep on a topic that is, well, it's absolutely fundamental to AI. And if you're building AI or deploying AI, you've got to get this right. It's AI model versioning and management.
It's like you know how in any iterative process, right? Like if you're coding or you're designing something or even cooking, you're constantly refining and improving.
Right.
AI is the same way. Our models are constantly evolving, and that demands careful attention and tracking.
Yeah.
You spend so much time, so much effort training an AI model, you finally get it performing well, but then, inevitably you're going to want to make changes to make it even better.
Right.
So then how do you keep track of, what worked, what didn't work, and most importantly, how do you make sure that you can always go back to a reliable version? And that's where model versioning and management comes in.
Yeah. It's really about more than just like saving multiple versions of a file. It's about understanding the complete developmental journey of a model. Right. So in this deep dive, we're going to explore what it is, why it's become so vital in today's, pretty intricate AI landscape. We'll unpack some of the challenges, and we'll look at some of the tools and best practices that can help you navigate this really crucial part of the AI lifecycle. Our mission today is to give you, the listener, a clear understanding of how to effectively manage your AI models as they grow, as they change. So let's get into it. Why is keeping tabs on AI model versions so much more complex than, say, something like versioning your software code?
Well, yeah, it's not just about having different files with slightly different names, right? One big challenge right off the bat is just the lack of standardized documentation and tracking practices.
Yep.
Imagine trying to reproduce a scientific experiment, but you didn't have, the detailed logs, the measurements, the conditions.
Like trying to follow the evolution of a groundbreaking invention, and all the blueprints are missing.
Yeah, exactly. And even small, seemingly insignificant, undocumented adjustments can have a really, really big impact.
Oh, wow. Yeah. There's this one case I was reading about where, this team was fine-tuning a model for fraud detection.
Okay.
And they made this really subtle change to how they handled missing data, right? Seemed minor. But because they didn't document this tweak, it led to this huge drop in the model's ability to actually catch fraudulent transactions.
Oh, wow.
And it took them weeks to figure out why their performance had tanked, and it all came down to this one little data pre-processing step that wasn't recorded.
So it's really important not just to document what you change, but why.
Absolutely, yeah.
Okay. So then there's also the whole challenge of managing dependencies. AI models, they don't live in a vacuum, right? They rely on very specific versions of software libraries, the underlying frameworks, the data sources. Yeah. It's kind of like, when you're setting up a coding project and you need specific versions of different packages. If you don't manage those correctly, you can get in these situations where the code works perfectly on your machine, but then, it throws errors somewhere else.
Right.
Same thing happens with AI models, but it can be even more complex. Different library versions can introduce subtle incompatibilities or even change the behavior of the model in ways you don't expect.
Yeah. And then another challenge is model drift.
Right.
This idea of, performance degrading over time. It's not like a piece of software where you get it working and it kind of just keeps humming along. AI models, they interact with the real world, and the real world changes. So as the data they're analyzing changes, the accuracy can start to decline, sometimes really rapidly.
This is what we call model decay, and it raises a really important question for you, for anyone working with AI. How do you know when your model is starting to lose its edge, right? You need ways to monitor for things like, data drift, where the characteristics of your input data are changing, or concept drift, where the relationship between your inputs and what you're predicting is shifting.
Right.
For example, you might have a model that's predicting housing prices, but if the economy changes drastically, those historical relationships that the model learned might not hold true anymore.
Well, that makes sense.
So when these things happen, when you have this drift, you need to be able to go back, look at your older model versions, and figure out which one was performing best and how the newer ones compare.
Yeah, and then adding to that complexity is this whole relationship between models and data. It's so fundamental.
Right.
A model's intelligence, it comes from the data it was trained on. So it's not enough just to version your models. You also have to keep track of which version of your data set was used to train each version of your model.
Yeah. And this is where this idea of co-versioning comes in, where you're very carefully tracking the versions of your data, your code, and your trained model all together.
Okay.
Because if you can't link back a model to the exact data set it learned from, you lose the ability to really reproduce your results or understand why a model is behaving the way it is. Imagine trying to understand why a medical diagnosis AI made a certain prediction, but you have no idea what data it was trained on.
Yeah, yeah. And then, we also have to think about the practical stuff, like scalability and resource implications.
Mm-hmm.
If you're keeping a history of all your model versions, especially for these, super complex models, it can eat up a lot of storage, a lot of computing power.
This is a real challenge, right? You need to think strategically about how to manage this growing collection of models without it costing a fortune or slowing everything down. You might need to explore things like model compression or figure out how to archive older versions that aren't as critical anymore.
Yeah. And then another thing, it can be surprisingly hard to replicate the exact environment that was used for different model versions.
Mm-hmm.
If you need to go back and test or redeploy an older version, you have to recreate the specific software, the hardware, the dependencies. It could be a real pain.
Yeah. And this is where containerization can be a lifesaver. Things like Docker allow you to package up your model and all its dependencies into a neat little portable unit.
Right.
And of course, then you version those Docker images as well, just to add another layer of control.
Yeah. And then finally, there's the challenge of integrating your versioning system with all the other tools in your ML workflow.
Mm-hmm.
Like, you have experiment trackers, deployment pipelines. You want to make sure that everything works together smoothly.
Yeah. If your versioning system is off on its own, it's going to be a pain to use, and people just won't use it consistently.
Hmm.
You really want a system that integrates nicely with the tools you already have.
Okay, so we've seen why tracking AI model versions can be such a headache, but there are tools out there to help, right?
Absolutely.
And these tools, they generally fall into a few categories.
Yeah, and what's really interesting is that we're seeing these tools evolve rapidly as people are realizing that, traditional software version control systems just don't cut it for AI.
Right, right. So first we've got these integrated machine learning platforms. The big cloud providers. Google's got Vertex AI, Amazon has SageMaker, Microsoft's got Azure Machine Learning.
Mm-hmm.
And these platforms, they often include something called a model registry. Think of it like a central library specifically for your AI models.
Right. This is where you can store your models, you can track their versions, you can manage all the associated information, and you can really follow their journey from development to deployment and eventually retirement.
Right, right. So for example, with Google Vertex AI, you can import new model versions. You can train new ones from within the registry. You can see a history of all the versions. You can get all these details about each one, and you can even set a default version for predictions.
Yeah, and the nice thing about these integrated platforms is that they're really seamless within their own ecosystems. So if you're already heavily invested in a particular cloud provider, their model registry can be a really convenient option. But, it's worth noting that they might not be as flexible if you're working across multiple clouds or if you need to do a lot of customization. And the costs can add up.
Yeah, that's a good point. So then there's also standalone version control systems. You're probably familiar with Git for managing code.
Yeah.
But for AI models, especially with the huge data sets they often use, you have tools like DVC, data version control, and LakeFS.
Right. DVC is really cool. It works alongside Git. It doesn't try to replace it, but it's really good at handling those large data sets, those complex experiments. And it really helps you make sure your whole ML pipeline is reproducible. Plus, it works with all these different cloud storage options.
Okay.
And then LakeFS, that brings that familiar Git-style version control to data lakes.
Oh, okay.
And that's really valuable when you're dealing with truly massive amounts of data, like, petabytes or even exabytes. It lets data scientists collaborate, experiment on different branches of data, merge their changes. It's really powerful.
Yeah. And then another tool that I've seen mentioned is Pachyderm.
Right.
And this one seems to really focus on data versioning and managing those really complex ML pipelines at scale.
Yeah. Pachyderm automates this process of tracking data lineage, so you always know exactly what data was used to train each specific version of your model.
Okay, so those are some interesting options. And then there's also, experiment tracking tools. MLflow, weights and biases, Comet ML. While their main job is to track all your experiments, all the parameters you try, the performance metrics, a lot of them also offer features for versioning models and even data sets.
Yeah. And what's really key here is that these tools give you that deep insight into why your models are performing the way they are.
Okay.
By meticulously tracking everything, you can understand how different settings and different data affect the outcome. And they're increasingly recognizing the importance of managing those final trained models as well.
Right, right. So for example, MLflow, it has a model registry, and every time you log a trained models from an experiment, it gets a unique version number. And you can track its life cycle. Is it in staging? Is it in production? Is it archived? It's all there.
And weights and biases and Comet ML also have ways to track and version your models, and it's all tightly integrated with their experiment tracking.
Okay.
So it becomes really easy to see exactly what experiment produced a specific model.
So there's a whole ecosystem of tools out there to help manage this complexity. And the best choice for you is going to depend on, your specific projects, your infrastructure, the scale of your AI work.
Absolutely.
So now that we've talked about the challenges and the tools, what about some best practices? What are some things our listeners should do to get model versioning right?
Well, the absolute number one thing is to document everything.
Okay.
Like, what data did you use? What versions? What pre-processing steps? What were the exact hyperparameters? How did you engineer your features? How did you evaluate the model?
Yeah.
Like, all of that needs to be documented for every single model version.
Right.
It seems basic, but you wouldn't believe how often this gets overlooked. You can use templates to make sure you're consistent, or you can even try to automate some of it.
Okay. And then, of course, we need to establish clear version control systems, not just for your code, which, hopefully you're already doing, but for your data, your configurations, your experiment results. Make it a part of your regular workflow.
Absolutely. And to really make this work, you want to automate your versioning as much as possible.
Right.
So, CI/CD pipelines are a great way to do this. You can build versioning right into your automated workflows.
Okay.
And that helps ensure consistency and that everything gets validated properly.
And use those model registries if you have them.
Definitely.
Whether it's through your cloud platform or a tool like MLflow, they keep everything organized. You can track the models. You can compare them easily.
And don't forget about naming conventions.
Yeah.
Like, using semantic versioning, major.minor.patch, can be really helpful to communicate what's changed in each version.
Right. And we talked about containerization earlier, but it's worth repeating. Use Docker. It makes your models so much more portable. They'll run the same way in different environments. And version your Docker images as well.
Absolutely. So you might be thinking, okay, this is a lot of extra work. What's the payoff?
Right.
Well, the benefits are huge. You get end-to-end traceability. You can trace a model all the way back to its origins. What data was used, what code, what parameters. That's so important for things like compliance and troubleshooting.
Right.
It also improves collaboration. When everyone understands how the models have evolved, it's much easier to work together, to learn from past experiences, to avoid making the same mistakes.
Right. And accountability. You can track who made changes, why they made them, and you can monitor performance over time to see if you need to make more adjustments. So really robust model versioning and management, they're essential for reproducibility. You can recreate experiments, you can recreate specific models. It's also crucial for auditability, for compliance, and for building responsible AI systems that you can trust.
As AI gets more and more integrated into our world, this isn't just a best practice anymore. It's becoming a necessity.
So we've just scratched the surface here, but hopefully this deep dive has given you a good understanding of why AI model versioning and management is so important and how you can start doing it right. If you found this information valuable and want to keep exploring the world of AI before we reach AGI, be sure to hit subscribe. And for even more hands-on insights and tutorials, check out my YouTube channel, Ian Ochieng. That's OCHIENG AI. Thanks for joining us for this deep dive.